When solving a system of equations, we have two options on how we can solve it, either algebraically or graphically. By looking at the system that we have here, we could solve this algebraically, and we could do that either by substitution or combination. Again, for substitution, we're looking for an x equals or a y equals, or one that we can make fairly easily. Based on the equations we have here, it would take a significant amount of work to make that happen, so substitution is probably not best. This would be a good one for linear combination, where we want the same amount for the coefficient of the variable, one positive and one negative, so when we combine them by addition, they'll make a 0. So as I'm looking at my problem here, I probably would like to eliminate the y, since one is negative and one is positive, and I can multiply the equations by a value to make them the same amount for the coefficient. So I can multiply the first equation by 3 and the second equation by 4, so my coefficients would be 12s to make my 0. So again, multiplying the entire first equation by 3, we'd have 15x plus 12y equals 9, and the entire second equation by 4, we have 8x minus 12y equals negative 32. By adding the equations together, we'll end up with 23x equaling negative 23. To get x alone, we could divide each side by 23, so x would equal negative 1. Now that I know the value for x, I could substitute that into one of my two equations and solve for y, and we'd go back to the originals to do so. So if I substitute my value for x into the first equation, now I can solve for y, so I could multiply, then I would end up adding 5 to each side, and then dividing by 4, so y equals 2. So it appears that I have a solution of negative 1, 2 for my system. The only way to be sure is to take both the values for x and y and substitute them into each of the original two equations and make sure I get back what I'm supposed to. So by substituting in the first equation, will I get back a 3? By substituting the second equation, will I get back the negative 8? So again, by substituting, we'll have a negative 5 and a positive 8, which should give me the 3. Then I would have a negative 2 and a negative 6, which would also give me the negative 8. So both work. Therefore, my solution to my system would be the location negative 1, 2. So algebraically, using the combination or elimination method, we could solve that system. Now you also could have done it graphically as well. We did talk about going back to those original equations, and in order to graph it, you need a y equals, because all the functions defined as the outputs equal something. So if you did decide to do it graphically, it would take some work to get the y's alone. And so if you did with that first equation, we'd have to undo it to get y's by itself. So we'd have to subtract the 5x, divide by 4. This is the function we'd have to plot. This is our y-intercept, so we plot our point at 0, 3/4, and we'd be going down 5 units from that point into the right 4 each time to create more points to generate my line, and the line would look like this. You've got your decreasing function because the slope is negative, and again, here's your starting point at your 0, 3/4. Again, we would say the same thing for the second equation, undo that to get y alone for there. So again, subtracting 2x, dividing everything by negative 3, we have y equals 8/3 plus 2/3 x. So my y-intercept would be at 0, 8/3. And from that point, I'd be going up 2 units and to the right 3 units. So I'd have my increasing function, which looks like so. And again, graphically, when you're solving your systems, you're trying to see where all the equations or all the rules meet at the same place, same time. And that happens here at our coordinate of negative 1, 2. Best method for solving the system we were given was probably using the elimination combination method. Regardless of the method that you're using, you should always verify your solution by substituting the values for your x and y coordinates into both of the original equations and making sure that they are balanced.